In this example, we will cover how to create a structural simulation and run a parametric design study in the 3DEXPERIENCE platform. Starting from the assembly, I will open the upper torque arm in a new tab. You can do this by right-clicking on the torque part in the branch and selecting Open in a New App from the drop-down menu. To start, I will open the Linear Structural Validation application. This app helps you set up a structural simulation. It will ask you to name the simulation and specify the simulation type. In this example, I will do a structural simulation. Next, I am going to open Assistant. Assistant gives you a step-by-step instruction on how to set up a simulation. The next step is to create boundary and loading conditions. I will clamp the upper two holes of the torque arm and apply a force of 125,000 newtons in the Z direction. Once all those requirements have been met, we can finally submit the simulation. You'll notice that all the requirements have a green check mark and the simulate button is green, showing that it is ready for submission. Once the simulation has run, the results show us the von Mises stress, factor of safety, compression and tension among other variables. Let's say we want to make some changes to the geometry and resubmit the simulation. In this case, I will change the offset parameter. These changes are easy to do. We can go back to the geometry and make any changes to any parameters we want. This will automatically generate the new finite element model, and the materials, boundary, and loading conditions will stay the same. The next step is to click Simulate. Using the Compare Results tab, you can compare the two different simulation runs to compare the geometry and results. Another tool that can help us find the best shape is called the Parametric Design Study. This tool lets you choose the parameters you want to explore while defining the objectives of your design. Using Assistant again, you can select the design variables. In this case, I will be varying the offset and radiuses. Next, I need to define the response variables or objectives. I will select displacement, von Mises stress, factor of safety, and atom mass sensor. I will specify that I am trying to minimize the displacement, stresses, factor of safety, and the mass of the torque arm. I will also specify that I am looking for anything that has a factor of safety greater than 1. Let's explore 100 design points and click Simulate. Once the run has finished, you will see the 100 design points that have been completed. Each design point has a specific offset and the radius. Notice that when I click on the different point, the geometry changes because the parameters are changing. You're also able to change the axis of the graph to see the relationship of the parameters to the response variables. On the right side of the screen, you can also see the design number, in this case 70, and the parameters that pertain to that design, as well as the response variables. Notice that I can also add the factor of safety on the x-axis on the graph, and it will show me the designs that have a factor of safety greater than 1. The red area shows the design points that do not meet the criteria of a factor safety of 1. Simulation on the 3DEXPERIENCE platform helps you have a digital continuity from the design phase, setting up a simulation, to viewing and comparing the results. Parametric Design Study helps you see multiple design points without having to manually create multiple iterations of your design. I hope you leverage these tools next time you design and simulate your product. Visit our Simulia YouTube page for more videos. Thanks for watching.